Well, hello again and welcome to the VK6CS amateur radio channel. Now I've got an enclosure for my amplifier. I know what size and shape it's going to be. I can visualize what the front panel is going to look like. So what it's going to look like is well, I know it's now is the camera going to stay in focus? That's the question, isn't it? Because moving in front of it, the autofocus might play up. But anyway, I'll give it a crack. I'll move a little slower. So let's say it's going to be an oblong box, something like that. Let's just see if that's in the shot. That's not bad actually. Let's move that over there a bit. Now I've got 3 panel meters because I want to monitor the anode current and the grid current and the high voltage at the same time. I don't like the idea of having a switch on the front where you switch between grid current and anode current. I think it's important that you see both of those at the same time. Now if you watch the previous video, you'll see that the power supply is going to be this third here. About a third of the front of the panel here is going to have the power supply behind it. There'll be a metal screen going from the bottom to the top and from the front to the back, separating the power supply from the amplifier itself. And in that section on the front panel there'll be I'm drawing this backwards, so there'll be a meter for the high voltage, be another one for the grid current, and there'll be another one for the anode current. Again, progressively smaller. It probably occurred to me that if I drew them all the same size I wouldn't squeeze them into that third. That's probably more than a third, but I'm sure you see where I'm going with that. So there'll be 3 panel meters, be anode current, grid current, high voltage. Below that, spaced nice and evenly of course, will be 3 switches. And you're going to think, wow, this looks an awful lot like an Ameritron. Well, probably will actually. So this first one here will be the heater and blower switch. So flick that switch, heater will come on, the blower will come on. Second one will be the HT switch, that will turn on the high volts. If I turn, it will be wired so that if I turn this on without this being on, the high volts won't operate, so I can't turn the high volts on without the heater and the blower being on. And this last one will be standby and operate. And what this will do is it will just switch the supply voltage for the RF switching relays on and off. So when the drive radio is connected, the keying line will be connected. Press the PTT on the drive radio, it'll activate the relays on here, and the relays will switch that drive energy through the amplifier to be amplified. When I release the PTT, the relays will drop back, and that drive radio will effectively be connected straight to the antenna for receive. Now if I then flick this switch to standby, it will turn off the supply volts to those relays, so that the next time I press the PTT on the radio, those relays won't activate and divert the energy into the amplifier. They'll let the energy from that radio go straight through to the antenna. And I think that's a useful feature, that, because if you're talking to someone you can say, okay, well, you know, this is what it's like with the amplifier, flick the switch. This is what it's like without the amplifier, flick the switch. This is what it's like with the amplifier. So I think that's a useful feature. So I have 3 meters there, and then 3 switches below that. As I say, that'll be set out nice, and it won't be sort of bunched over to this side as it appears here, you know, 3 meters, and then evenly spaced below those. Down here somewhere will be the 3 switches. Then there'll be a, hope that stays focused, then there'll be, for the main tank circuit, there'll be 3 controls. Pretty standard arrangement. Have probably that one will be tune. It's probably going to be the biggest capacitor if I use an airspace one. That will be the switch, band switch, and that will be load. So it's looking pretty traditional so far, isn't it? So just three knobs there: tune, band switch, and load. And the input circuit is going to be an L circuit, so I'll just have a capacitor and an inductor, and I'll probably position those again in a nice sort of linear position, so it's got a nice looking layout to it. I have one there and one there, and that's probably going to be a capacitor, and that will probably be the inductor. So I reckon that's pretty much what it's going to look like. I'll paint this panel satin black to match the rest of the case, so it should look like a commercial unit when it's finished. Well, probably apart from the writing on the front panel, because I'll write labels and stick them on, rather than it's not going to be it won't be screen printed. Although, having said that, if I know exactly where all the bits are going, I suppose I could get a company to make the panel and screen print it. But I'll probably end up doing it the hard way. I'll do it by hand. You know, I'll just drill holes, and then I'll drill holes and then file it into an oblong. I may have a chassis punch for the meter sizes. If not, that's going to be fairly hard work. And it's certainly going to be hard work cutting the round hole in the steel case in the top and bottom for the air intake and the exhaust through the valve. Not looking forward to that one, but anyway, it's got to be done. All right. Well, that's just while I've been sitting in my comfy chair thinking about my amplifier, that's what sprung to mind. So if you saw the last video and you saw the enclosure there with the front and rear frames and the detachable side panel, I think I mentioned there's one on each side, so that's a really great feature, having those detachable side panels. Then that's what it's going to look like when it's finished. So anyway, I just thought I'd do another quick video while I was chewing this over. Hope you found that interesting, and as always, many thanks for watching. I'll catch you next time.